Alright guys, let's go ahead and check these three from Thursday. We never checked them. It got to the end of class, and we never went over them. What did you get for your solution for the first one? What was your solution for the very first one? Elena? -1.5. Raise your hand if that's what you also got. Alright, so your first one you should have gotten -1.5. Everybody good on that one? Yeah. Everybody good? Cool. What did you get for second one? 1 what? 1.3. Perfecto. 1.3. If you checked your work, you should have got them all. All should have turned out wookie doke. And what did you get for last one? Clay? 3.3. 3.3. Not too bad? Pretty good? Yeah? Cool. Alright, so let's talk about those word problems. So when it comes to systems of equations with word problems, you have to create your equation first. Then after you create your equation, then you have to solve it, figure out what it is. Okay? So I have two questions here for you, and we're going to do these together. The first one, can I have a volunteer to read it? Elena?
Sarah and Josh are selling tickets to the school play. On the first day of selling, Sarah sold 5 tickets and Josh sold no tickets. Each day after that, Sarah sold 2 tickets and Josh sold 3 tickets. At how many days will they have sold the same amount of tickets?
Okay, so we're trying to figure out at how many days will they have sold the exact same amount of tickets. So we know we're going to have a solution, right? We should have a solution. If these turn out to be parallel lines, then I guess never. But they should have a solution. So we've got to create some equations here. One equation is going to be for Sarah, and one equation is going to be for Josh. So let's focus on one at a time. Let's write Sarah's first. This will be equation number 1. So on the first day of selling, Sarah sold 5 tickets, and Josh sold none. Each day after that, Sarah sold 2 tickets, and Josh sold 3 tickets. At how many days will they have sold the same amount of tickets? Well, before we can even write these equations, what do we first have to identify? Kayla? Nope. What do we first have to identify? Alec? Nope. What do I have to identify? When you're creating an equation, you always need to identify what? Valerie?
The first point.
No. When you're creating, guys, we created equations a bunch last year. When we created equations, we always had to identify what something meant. Variable. We always, not always x. We always have to identify what our variables mean. Do we want to use x and y, or do we want to use something else? X and j, okay. Oh, s and j. I don't know that we should use s and j. Let's use x and y. Let's use X and Y. If you want to use S and J, you can, but let's just use X and Y. And what is X going to be? What is X going to be? What are we trying to figure out? Clay or Luke?
Where it's positioned on the x-axis?
No, what is X going to mean? What are we trying to figure out? Ella? No. Read the problem. Read the problem. Variables always mean something that we don't know the value of yet. What do we not know the value of yet? Valerie? No. No, yes, sorry, yes. Okay, so one of them is the days. We want to know how many days will they have sold the same amount of tickets. Okay, so we can call maybe X the amount of days. So what should we call Y? If X is the amount of days, what should we call Y? Tickets sold. So from there, could we kind of label our axes? Yeah. Days. Tickets sold. So let me ask you a question right now. Why do you think I didn't separate this into 4 different quadrants? You can't sell a negative amount of tickets. So does it make sense for me to include any other quadrant except for quadrant 1? No, it doesn't. So I don't know. Let's label these by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this by ones too. 1, 2, 3. So now we know what our 2 variables are going to mean. Valerie, you see now why I didn't want to use S and J? But one equation is going to represent Sarah and one equation will represent Josh. All right, so day 1. Day 1. First day of selling. How many tickets did Sarah sell? 5. Okay, so I know that Sarah, she started by selling 5. So if she started, first day, sold 5 tickets, that could represent our what? Luke? Y-intercept. I know if she started with 5, and I know that y-intercept is kind of our starting point, I can kind of, off to the side here, go plus 5, right? I know that's where I'm going to start her equation at 5. What about Josh? He started with 0, so what's his y-intercept going to be? 0. So have we taken, on the first day of selling, Sarah sold 5 tickets and Josh sold no tickets. Have we kind of addressed that sentence? So we're going to take it sentence by sentence. Each day after that, Sarah sold 2 tickets. So every day, Sarah sold 2 more tickets. So that 2 is going to represent our what? Our slope. Every day, Sarah sold 2 more tickets. We know that X is the number of days, and she sold 2 every day after that. Does that make sense? If X is the number of days and she sold 2 tickets every day after that, are we good? Now, what does this have to equal? Why? We're trying to figure out how many tickets she sold in all. So no matter what day we put in there, we can figure out how many tickets she had sold. Josh sold 3 tickets every day after that. So how can I finish his equation if I know he started selling none? Clay? Think about how we did Sarah. She sold 2 tickets every day. Huh? 3x, right? So for Josh, his slope is 3. And does that still have to equal number of tickets sold? Mm-hmm. Yes. Have I created 2 equations? Mm-hmm. Yeah. So now, before I start graphing, I better make sure that these equations make sense. Sarah and Josh are selling tickets to the school play. On the first day of selling, Sarah sold 5 tickets. Cool. Josh sold none. Each day after that, Sarah sold 2 tickets. So each day she sold 2. And Josh, each day he sold 3. And that's going to equal the amount of tickets they sold altogether. Are we good? Sweet. So let's start graphing these. So even though Sarah on the first day sold 5, and we know that that's our y-intercept, isn't 5 kind of like the 0th day, so to speak? If we know that 5 is our starting point, isn't that our 0th day? All right, so I'm going to start by going up to 5 on my y-intercept and plotting a point, because I know that's where Sarah started. How many tickets did she sell on day 1?
2.
She sold 2 more, right? So now she sold 7 tickets in all. How many tickets did she sell on the day after that? 2 more, which makes it at 9. Can I use my slope to help me with this? Yes, I know that she sold 2 every day, so my slope is 2 over 1. Increase by 2, increase by a day. She sold 2 tickets on this, 2 more tickets on this day. She sold 2 more tickets on this day. Make sense? So on day, what is this, 5, she's already sold 15 tickets. All right, so I'm going to get all my points together. Draw my arrow. Now, why do you think I only drew an arrow at the top? You can't sell negative tickets. Now, technically, does this line still go on and on forever in the other direction? Yeah. But does that make sense for our problem? No. So when we start talking about things like domain and range in a couple weeks, okay, and finding appropriate domains and ranges, this knowledge will come in very, very handy. Cool. So let's look at Josh. How many did he start with? 0. Lazy bones. He didn't sell any.
Maybe people didn't like him.
But then, how many tickets did he sell every day after that? 3. So he sold 3 tickets after that. Then he sold 3 more 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 after that. So now let me create his line. Oh, I didn't label hers. I'm going to label this Sarah. I'm going to label this Josh. Have they reached a point where they have sold the same amount of tickets? On what day have they sold the exact same amount of tickets? Day 5. And how many tickets did they sell on day 5? 15. So can I create some sort of ordered pair for that? What's my x value mean again? Days. So after 5 days, so that should be my x value. And what does my y value mean? Number of tickets sold, which was 15. Does my ordered pair make sense for my answer? Did they both sell 15 tickets on day 5? Yes. Could I check my answers now? I sure could. Because that's what good mathematicians do. What am I plugging in for y? 15. And what am I substituting in for x? 5. Two times 5 is 10. 10 plus 5 is 15. That works. 3 times 5 is 15. That one also works. So am I confident in my answer? Have I determined at how many days they would sell the same amount of tickets? And what is that answer again? 5. Simple? Not really? What do you think could be the most difficult part of this whole process? The graphing? Okay. What else do you think could be the most difficult part of this problem? What if you don't get the right equation? Then everything is wrong after that. So what do you have to make sure before you start graphing is correct? Your equations. That's why I took so much time in the beginning to not only write them out, sentence by sentence, but go back and make sure that they still made sense. So far, so good? All right, let's do the second one. The place to be bowling alley, charges a $2 shoe rental fee and $3 per game. Bowling B, the best bowling alley, charges a $4 shoe rental fee and $2 per game. For how many games will it cost the same to bowl at either alley? So what are our two equations going to be this time? Last time it was Sarah and Josh. What are our two equations going to be at this point? Luke? The two different bowling alleys. So we're going to have the place to be bowling. And I'm just going to, instead of writing it all out, wasting a lot of space, I'm just going to put the place to be bowling. Does that work? No. And what's the second one going to be? I'll just put bowling BT best. BBTB. Alright, so the first one, the place to be bowling. How much do they charge for shoe rentals? $2. And then how much do they charge per game? $3, okay. Bowling B, the best bowling alley, charges how much for their shoe rental? $4. And how much per game? $2. Okay, cool. So what should our variables mean? If I have my variable x and y, what are they both going to mean? What do you think? Think about what can change and think about what's going to stay the same. Clay? I'm going to disagree with the shoe rental fee. Because is the shoe rental fee going to change? No, shoe rental fee is not going to change. Is everybody going to have to pay $2 or $4 to rent their shoes? Yes, and is that shoe rental per game? No, so I don't really need to label a variable that, because that's just kind of walking in the door. I need to pay either $2 or $4 if I didn't bring my own shoes. But I will agree with you about the per game. So Clay, which variable, x or y, do you want to say cost per game? Or number of games? X or y? I'm going to disagree with you there as well. Let's think about what we know about our x and y axis. What else could we call those? Think about science. You have two different variables. You have two different variables in science. What are they?
I don't know. Depends on what you're doing.
There's always two different types of variables. Ryland? You have your dependent and your independent variables. Okay? Where your independent variable can exist on its own, but your dependent variable is dependent on something else. So if we're looking at our graph, our x-axis is what? The dependent or the independent? The independent. And our y-axis is our dependent. There's only one other option, right? If our x-axis is our independent, that means our y-axis is our dependent variable. So I'm going to say that x is the number of games. And y is the cost. Do you agree that the number of games you play, or let me work this backwards. Do you agree that the total cost is dependent on the amount of games you play? Okay. So, I want you to see if you can create an equation for these two. See what you can get. All right, what did you get for TPTBB? What? Y equals 3x plus 2. Raise your hand if you got the same thing. Sweet. So does this say that the total cost that you will pay is equal to $3 per game plus your $2 shoe rental? Yes. It does. Cool. So what about BBTB? BBTB. Sebastian? So does this say the total cost that you will pay is equal to $2 per game plus $4 shoe rental? And does that match it up here? Sweet. Can I graph them? Yep. What am I going to label my my x-axis? X-axis. Number of games. And what am I going to label my y-axis? Cost. Cost in dollars. Do I want to go by ones, twos, threes? Ones, okay. It doesn't matter what you go by as long as it's accurate. All right, so now I'm going to graph them. For the first one, I'm going to go up to 2 because that's starting point. I got to pay for those shoes. And then for each game, I'm going to pay $3. So one game, I paid $3 more. Second game, I paid $3 more. Third game, I paid $3 more. Fourth game, I paid $3 more. Connect the dots. So again, I'm going to ask you, why do you think I didn't include quadrants 2, 3, and 4? You can't play a negative amount of games. So does it make sense for this problem?
No.
No, it doesn't make sense if I had the other quadrants. So do you see how I only put the arrow here? Do I still know that this line could go this way? But does it make sense for the problem? No. All right, so this one was TPTBB, the place to be bowling. Second one, I'm going to start here at 4 because their shoe rentals are a little bit more. And then it's $2 per game. 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 And now I can make that line. Ooh, these points are very close together. Very close. And that is BBTB. Bowling B the best. Let me zoom in on this here. Do they have a point where it doesn't matter how many games you play, you're going to pay the same amount? What is that? How many games? 2 games. So if you want to play 2 games, it don't matter where you go. Okay. So could I create myself an ordered pair to represent the point that they intersect? What is that point? 2, 8. So that means for 2 games, they're going to pay how much monies? 8 monies. $8. Do I need to check my work? Yes, I do.
Even though you don't want to.
Even though you may not want to, is it a good idea? Yes. What if this question, you get it right, you get $1 million? Would you check your work?
Yes.
Mm-hmm. What am I going to
Me, I probably would.
What am I going to substitute in for y? 8. And for x? 2. Whoops, that's supposed to be a 2. 2 times 3 is 6. 6 plus 2 is 8. It works there. 2 times 2 is 4. 4 plus 4 is 8. It works there. So let me ask you a question. What if you only wanted to play 1 game of bowling? Which bowling alley would you go to? You only wanted to play 1 game, and that's it. You're done. And you're trying to do it very cost effectively. So which bowling alley would you go to play only 1 game? The place to be bowling.
Yeah.
I agree. What if you go with a group of friends and you guys want to play like 10 games of bowling? Bowling be the best? Right. So if you wanted to play more than 2 games, you should probably go to bowling be the best, right? But if you wanted to play less than 2, you should go to the first place. But if you wanted to play exactly 2, I would go to the one closest to my house. Make sense? They're exactly the same distance, and I don't know. I just pick one. I would just pick one.
Which one's you pick the one with the best pizza.
There you go.
What is it?
But in Boone, we only have 1 to choose from. But am I confident in the fact that after 2 games, it doesn't matter where they go? Cost the same. How do you feel about this?
Pretty good.
Pretty good? Like on a scale of 1 to 3, 3 being an expert, 1 meaning I don't know, and 2 meaning sorta kinda. Where are you at? Ryland? Where are you at? 1, 2, 3. Alright, well, I'm going to give you a very brief assignment to work on. It's 3 questions.
That's 2 minutes.
3 questions. The first 2,
That's 4 questions.
the first 2, you're just graphing the system, telling me a solution. Yes, you must check your work. Same with the second one. And then there is one lonely little word problem. You need to write your equations, label your axes, just like we did on the examples, and check your work in the end. You can put your final answer up here. Yeah, but you have 5, 10, 15, 20 minutes to do it. Plenty of time. Any questions on your assignment? Okay. As soon as you get it, you may begin.